Now I get the bugs out of resistance. Okay. Thank you, DJ. What did we say? The 34?
38.4.
38.4 amps. 38.4 amps. Okay. So welders arc 630.11a, 630.11b. The cycle, based on the cycle, based on motor, non-motor, we come up with these multipliers. Any question, guys, about motor number 2? Motor number 2 is 90% cycle, 40 amps. You multiply it by 0.96 based on the cycle. You multiply it by 1 because it's one of the two largest. Okay, let's go down to the 30 amps. 30 amp multiplied. Okay, let's look at the cycle. The 30 amp has a cycle of 80. Is it still motor? Under motor. 80 motor, 0.91, right? Everybody see that? 0.91? 0.91? 0.91. Where did I come up with 0.91, Mr. Erbab? This is coming from table 630.11a under motor generator for an 80% cycle motor generator arc welder. Okay, now, is 30 one of the top 2 in the system? No. Okay, let's see what it says underneath it. Plus 85% of the third largest. Is 30 the third largest in the system? Yeah. So you're going to multiply it by, because it's the third largest, we're going to multiply it by 85. What do you say? 85. So I need to multiply by 0.85. Any question where the 0.85 came to be? Because it's the third largest. The third largest from B, 11B, it says you multiply by 0.85. 91 is coming from the cycle of 80% for motor generator arc welder. Anybody come up with the calculation?
23.
23. Let's make it 23, guys. 23. Yeah. 23. And you know what? Anything less than 0.4. This is 38. Let's make it 38 amps. 38 amps, 23. Anything less than 0.4 or 0.5, drop it. Okay, let's go to the fourth one. The fourth one is, what's a cycle for the fourth one? It's non-motor, and it's the fourth one, and it's 20 amps. So here's a 20 amps. What's the multiplier for 70% cycle under non-motor this time? 0.84. So it's a 0.84 times. Now, this is the fourth largest. What does it say, the fourth largest, guys? Third plus 70% of the fourth largest. Is 20 the fourth largest? Yeah. So it's going to multiply by what? 0.7 equal. What would that give you? How much? 12. 11? Yeah, 12. 12 amps. 12 amps. Okay. Are you guys following? Really straightforward when you put it in this format. The last one is 10, or the one before the last is 10. The duty cycle is 60 under non-motor. 60 under non-motor is 0.78, right? 0.78. 0.78 times. Okay, now let's see, where are we? 70% of the largest plus 60% of the remaining welder is 10 amps, one of the first, second, third, or fourth largest. No, it's the remaining after the fourth. So all the remaining after the fourth largest, what do you do to them? 0.6 across the board. 0.6. 0.5 or 0.6? 0.6. Yeah, 0.6. Don't confuse me. And what did you guys come up with there? 4 amps?
I got 4.68, but wouldn't that just be 5?
4.68 for 5 amps. Just anything higher than 5, just make it 1. Okay, the last one, guys, is I have a 5 amp times, what's the cycle for it? Is 50. 0.71 based on the cycle, 0.71 times based on its location amp wise compared to every other welder in the system, it sits at 0.6. 0.6, what do you guys come up with? 2 amps. Come up with 2 amps. That's it. If you have more welders, what do you do? Keep adding them. Yes, sir.
spend 2 hours, but that's it.
You spend what?
You said we're gonna spend 2 hours, but that's it.
Oh, that's it for this example. Yeah.
What if we had 650 amp welders?
Then the first two, then you use the first two largest, which is the 260s, and then the third largest, which is another 60, and the fourth largest with another 60, and then you continue. Yeah. Good point. First two, basically all these 60s are going to be the first, the second, the last, all of them. Any question, guys? Any question about that? I need somebody to add them up for me. How much? 130. So if you add them all up, equal, how are we going to do that? Equal 130 amps. 130 amps. 130 amps. Okay? So here's all my, let me just draw a little my nice panel here. Here's how many welders do I have. All my welders. 1, 2, 3, 4, 5. Oops. Oh, come on. Give me. Here's all my welders, guys. How many do you have? 1, 2, 3, 4, 5, 6. Do we have 7?
6.
The number of welders.
6.
6 welders? Okay. 6 welders. So we'll erase that one. Here's my panel, and I'm only interested in sizing the panel. Not interested in sizing anything else other than, here's what I'm going to size. I want to size the following. Number 1 is the panel. Number 2 is the overcome protection device. Number 3 is conductor. Number 3 is the conductor. And since I'm going to drill that thing in your brain, guys, this is my neutral. This is my ground. My bonding conductor between them, that would be number 6, and the ground is going all the way to Mother Earth. That will be my 5. Okay? Like we did all the time, guys. We're going to size these 6 things for this system. 6 things for this system. 1, 2, 3, 4, 5. 5 things. Thank you. That's big spaghetti, doesn't it? Glad you're with me. Number, would you say this is 5 and this is will be 4? Okay, this 4 things for this system. Like any other system, guys, we're going to size these 4 things for this system. Panel wise, let's go panel wise. Let's go size the panel. Number one is panel size. Panel size. Okay, what do? We take the 130 amp, take it to D and volt. What voltage system are you going to run these boys at? Shall we run them at 208, 123 phase? Let's run in 208, 123 phase. I'm going to run them at 208/123 phase. These are all 3-phase welders. Okay? So which is it 312? 312, right? What size panel? 150 or 125? Do I have 150 or 200? 150. 150 amp. So what size panel do I have then for this system? 150 amp panel. What voltage? 208, 120. It could be any voltage, guys. I decided to go by 208, 120. Number 2. Any question? Any question? Any question, guys? Sorry for that. Any question, guys? For number 1, number 2 is happens to be the overcurrent protection device. Overcurrent protection device. I want to bring your attention to one article that talks about it, guys. 630.12. 630.12b. 630.12b. If you read through it, it says you cannot go higher than 200%. Look at exactly the term that they use. You on the conductor, you can't go higher than 200%. So I can go as low as I want, but I can't go higher than 200%. Unless they tell me otherwise, this is how I would do it. I take my 130 amp to 40.6. What would that give you the next standard? 250? 150. 150. Now here's my question for you. Is 150 higher than 200%? I can go as high as 300 on this system. As high as 300 in the system. But since I'm feeding a panel, here's my problem is, since I'm feeding a panel, I can go as high as double this, which is, what is it, 200%, 300? If I do this at 300, then this panel has to be 300. You can't put a 300 amp fuse or circuit breaker on a panel that's 200. So unless they tell me otherwise, I'm going to size my panel to 200, based exactly directly on the load, and my overcome protection device to match my panel or be smaller. That's what I did. So I have 150 panel, 150 overcome protection device. Okay. The last one, guys, number three, conductor or feeder. Again, you can size, Brooks, my friend, you can size based on 130 because it's less than 800 amp, but since it's feeding a panel, always match the overcurrent protection device. So I'm going to say here, match overcurrent protection device. That's piece of cake, Chad. In 150, take this one to 310.15B16 under which column? 75-degree column. And that will give me number 1 out. How many? I'm going to pull full neutral. I'm not going to get into the neutral. Full neutral. 3 conductors plus ground neutral. So I have 4 conductors. Number 1 and an aught and a DAWG. Okay, so I wired this panel with 1 aught, 4 conductors, full neutral. Now, Brad, if they ask me to do the branch circuits here for each one of these welder, you can size the branch circuit based on the full load current, guys, for each one of these welder, and the overcome protection device, you can go as high as 200% of that. So, for example, for this welder, if this welder was 50, first you derate it based on that derating stuff. After you derate based on the table, 1 welder, say you end up with from 50, 40, multiply by 2, 80, the overcome protection device will be no more than 80. And the conductor size, you can size it for 40. We're only doing the feeder, guys. We're not doing the branch circuits. Any question about this? Can I do now 4 and 5? Mr. Rebeb? We're good? Okay. Let's go number 4. Number 4 was the grounding electrode conductor. And this will be sized directly based on the conductors, which is number 1 aught. You take this one directly to 250.66 table, and you end up with number 1. Number 6. Number, how many? 1 conductor, number 6. Everything is covered. A, W, and G. Okay, number 5. Main bonding jumper. Main bonding jumper, the same thing, guys. 250.28, and it takes you to table 250.66. And since you guys think that these are more than 1100 kcm, the 1 aught, no. So that will give you the same number. 1, number 6, A, W, and a G. A, W, and a G.
you ever go bigger than 3/0 if it's over 1100 ACMs?
Only if it's a main bonding jumper, then you become 12.5% of the service conductors. Your question should.
Yeah, I just thought there'd be something referring to that in this, in the DeWalt.
And DeWalt, write them. You'll get a free copy next year. Any question, guys, about the grounding electrode conductor and the main bonding jumper? Grounding electrode conductor and main bonding jumper.
Are we taking the NVK with one off and going to that table?
Absolutely. Absolutely. Thank you. Maybe I should have done it this way. Main bonding jumper. Thank you, Mr. Bev. You take the same thing. Number 1 aught. And this is main bonding jumper. Yeah, you take the 1 aught exactly the same way. Except to see what the reference I put 250.28, so it reminds you that at one time you might have 12.5%.
Quick question.
Yes, sir.
You have your DeWalt, right?
DeWalt, yeah. Page
515.
page 550.
Yeah,
5-50,
15.
5-13,
If I'm interpreting it
5-50.
right.
Yep.
So the electrode conductor never exceeds 3/0.
Yes.
But if the
Yes.
bonding jumper is over 1100, then you
Then you.
12.5.
Yes.
All right.
Yep. Absolutely.
Okay.
Yeah. A grounding electrode conductor does not need to be more than. Can you make it 4/0? 250? Very cover as much cover as you want. But it doesn't need to, based on the code, to be more than 3/0. We did substation, guys. We did medium voltage substation. The standard was 4/0 cover buried underground for the grid. 4/0 cover standard. You know, even though it says 3/0, but our standard was substation, medium voltage, 4/0. You have gridded a foot by a foot grid of cover under the substation, grounding grid they call it, or grounding mat. Okay, any question, guys, before I have one more? So really is as you can, if DJ, I know you ask about sheets and working sheets. You can make this one as a working sheet. You can go just change the amps here, change the percentage here, and make as many worksheets as you want. You know what I mean, to work with it. Really nothing. This picture, right, and which is going to be PDF, guys. This one cover everything that you need to know about this type of welder, the arc welder. Really is. That's why I picked different motor, non-motor. Highly unlikely you're going to find all this mixture in one place, guys. They either go motor or non-motor in one shop. But I mixed them, different amps, different cycles, just because to get you all these scenarios. Any question, my friends? Do you need a break before I need another probably at least half an hour to do the second one? Do you guys want a quick run to the bathroom before I start my second welder? Which is going to be a resistor welder this time. I see the excitement coming out of Mr. Blue, man. Mr. Webb, what's your problem?
Yesterday and today.
Yesterday and today? I'm going to leave it until I'm done. You don't mind? Thank you, Mr. Webb. May God bless you, Mr. Webb. Hope you didn't take this one, give me fire and talk about religion here. Okay, resistance welders. Welders. It's the welders, right? So Brad doesn't yell at me. Welders. And this type of welder, guys, is called resistance. Resistance. Have a resistance. Don't ask me too much what's the difference between them. If you ask me, I'm going to send you to my friend Rich and he explained to you. Okay, for all what I need to know is, this is the type of the welder, a resistant welder, not an arc. You can argue a resistant will create an arc. but I think it's the other one is supplemented by some type of fuel. Yes, yeah.
Okay.
I was surprised when they told me that you actually have arc resistance and you supplement gas at the same time. It's really cool. Yeah. Okay. So for this one, I want you guys to go to 630.31a, 630.31a, and in particular, I want you to go to the table. In particular, to table 630.31a, and there's a number next to it, isn't it? 2. So if you guys review this, it will tell you and B. Did they say A and? Would that be looks like an and B? If you guys read A and B, 31A and B, it will tell you very easy. You take the full load amp, multiply by the based on the cycle, multiply by the multiplier, and then the largest one is 100. If you read B, guys, it says the conductor blah blah 2 or more welder shall not be less than the sum of the value blah 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 of the largest welder plus everything else is 60%. So you take the largest at 100% plus everything else as what? At 60%. So let's take an example. Very easy example like we did. Very nice table. So I'm going to do a table. Just if you want to plan accordingly. Here's my table. The same, similar to the table. This is my number. I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 6 welders, guys. Like the same one. This is full load amp. Did we do the cycle first the first time? Let me just be consistent one time in my life. Yes. We did the cycle first. So let's do the cycle first to be consistent with what we did. This is the number. This is okay. Cycle. This is full load amp. There is nothing motor, non-motor. For this one is nothing. It's because it's arc, and that's about it basically. There is no motor, non-motor. Okay, let's take the number 1. Welder number 1, guys, happen to be 50 amp, and thank you. This is cycle, Chad. I did the opposite this time. The cycle is 50. I have 50 cycle, 50 cycle, and believe it or not, 50 amp too. Motor number 2, the cycle, motor number 2, the cycle is 40%, and I have a 40 amp. I like the matching business here. And number 3, motor number 3, my friend, I have a cycle of 30. Okay, so motor number 3, I have a 30% cycle and 30 amps. 30% cycle and 30 amps. And motor number 4, I have a cycle of 20. The cycle is 25 cycle and 20 amp. 25 cycle and 20 amp. So I check 25 cycle, 20 amps. And the last 2, I have room for the last 2, hopefully. The last 2, number 5 and number 6. Number 5, guys, is 20% cycle. And I'm really picking these out of the hat here, 20 amp. And the last one is 5% cycle. Would that make a sense? 5% cycle. And I have a 5 amp. Okay, so these are all nameplates. Can I write to you guys name? Plate.
I got a question.
Yes,
Even
sir.
when you're doing like the ones that were motor on the other ones or whatever, you don't take them off the motor, the full load.
The other ones?
Yeah, you know, we had motor and non-motor.
Yeah, if they were motor, we take them under the motor. If we're non-motor, we took them under the non-motor.
You want to go to the motors?
Oh no, I mean 430. No. You mean Article 430?
Yeah.
No. Good point though. Gosh. Never thought about this motor, because it says motor generator. Then where are you going to go to 430 or 445? Yeah, don't even go there. How they make that system work. cycle full load amp, 50 all the way to 5 cycle, and 50 all the way to 5 amp, guys. These are my systems. Okay, and then I need to do the calculation. The calculation, I'm going to group this is it's actually right in here. Here's the calculation will be based on 430.31a and b and this table. So all the calculation, guys, will be based on these articles and table. Okay, the calculation will be based on the articles, the article and the table. Okay, let's start with the first one. The first one, guys, 50 times what's based on the cycle. What's the multiplier? Based on the cycle, my multiplier 0.71. Yep, 0.71. And based, and I'm going to go do this in a different color. Based on the largest, is this the largest? Is 50 the largest amp welder in the system? Yes. Then if you guys look at B, it tells you this has to be multiplied by 100%. So this is where 1 comes to be. Mr. Rebel, you're going to ask me where's this green 1 came to be? This is from B, where it tells you the largest welder, leave it alone. Multiplied by 100%. Okay? Piece of cake. Then the second one. The second one has 40 amp multiplied by, for a 40 amp multiplier is what? 0.63. Right, guys? 0.63. Correct me if I'm wrong here. 0.63 times. Okay, now, if you guys read B, B tells you take the largest at 100%, everything after the largest at 0.6. So this will be a 0.6. Okay, is it right?
Dan,
Yes, sir.
Can you show me where it says the first one at 100%?
Read B. Are you under?
The capacity of conductors that supply 2 or more welders should not be less than the sum of the value obtained in accordance with 630.31a or the largest welders.
For the largest.
For the largest welder, whatever. And 60% of the value.
Supplied and 60% of the value of the values obtained from all the other welders supplied.
The capacity of the conductors that supply should not be less than the sum of the value obtained in accordance with 630.
After you derate it,
When did we rate it?
here,
Okay.
right? That's after you derate it. Then you multiply by 100. I know it's
It's worded.
because it's the largest. The largest, guys, means after you derate it.
Just tell me it's the sum of 50
Yes.
times 0.71.
Yes.
I don't need 100%. It's just 50 times 0.71.
Okay. Okay, so it's the largest. It doesn't say at 100%. The largest meaning don't derate it. That's why I like to put the 1 because before, guys, we derated. So the largest, leave alone. This is where the 1 came to be. But you have to derate based on the table, though. Okay. The second one, guys. The third one is 30 times. Oops. Let's continue with the same format here. Once in our lifetime. 30 times 0.55 times 0.6, 0.6, all these are 0.6 times 20 times for 20, guys, is 0.5, I believe. Correct me if I'm wrong. 0.5, and for 10 times, for 10 it's 0.45, 0.45, and for 5 with a 5% cycle is 0.39. 0.39.
No, you're way off.
Am I off? Okay, where am I? Which one is which one here? That one?
No, you're
20. Well, you have a
20 is point.
you have a 25 amp right there.
After 30.
25 is 0.5.
But when you put 20, it's
20? This is 25? Where did you get 25? Is it 20 amp?
No, it's
Oh, this is 25%? Okay, 0.25. 0.25. Okay, how about that one?
No, no. That was, you're right.
25.
20 amp, 25%.
20 times-
0.50. That was right.
4.5.
Hold a second, guys. Hold your horses.
Or 0.45, yeah.
Times 0.45, right?
5% by
20.
Mr. Erbeb, 20 amps multiplied by 0.45 from the 25% cycle.
The 25%.
25% is
0.55.
25%.
25% is 0.5. Okay,
0.50.
so this should be 0.5.
20%.
0.5. Okay, for a 20% cycle, for 20% cycle, what's the 0.45?
0.45 is 20%.
20% cycle
20% is
is 0.45, that's right.
You're correct.
And,
0.22.
and for a 5,
0.22.
5% is 0.22. Thank you. 0.22. Where was I wrong? Where did they put 0.39? I bet you I was looking at.
30.39 on that, but it's 15%.
I know what the problem is. Okay, let's do it this way. So 5% cycle, 0.22. Okay? Everybody see that 60.6.6 across the board except the first one. Yes, sir.
Where you got that 0.6, is that part B?
0.6 is part B. Read at the bottom of the paragraph. Part B says 60% of the remainder after the first
Okay.
largest.
So that 20 right there should be 0.45.
No,
20?
that's 20 amp.
20 amp multiplied. What's the multiplier for 25%?
0.45.
Is that
0.5.
0.5? I think
You're
you're
right.
just. Yeah, you have to use a.
Where are you pulling in then?
Resistance welder table.
From the
Which one?
table. From the table. 630.31A2.
Right here in the
Yeah,
bottom?
yeah.
It's 0.45.
Go 25% is
0.5.
0.5. 25% cycle.
25% is 0.45.
Yep. Does it make sense? Does it make sense, DJ? No?
It doesn't match, but so it's here.
The 20% cycle is 0.45.
20% is 10 amps, and that should be 0.32.
Huh?
You're looking at amps, not percentages.
Don't look at
You wanna
this
look at
side.
percentages, not
Cycle.
amps.
Look at the cycles here.
20%
amps.
cycle is
Okay? I need somebody to give me the answer for all this stuff.
I don't bear. 36.
You don't care?
No, I don't bear your name.
Oh, dear. I thought here. Okay. All right. Let's. I'm gonna erase this one. I have a luxury. What's the answer?
36, first one.
All. Let's do. You guys want to do them this way? Okay. What was the other? The first one? 36 M. The second one? 15 M. The third one? Gosh, you guys are slow. What's going on with you? No coffee or something?
Well, I said 10,
10. This is 10. Fourth?
6,
6. Thank you.
3,
3.6.
46.
Let's make it 1. M. Okay.
4, 10, 20, 45.
Anybody disagree with Brad? Okay, we're gonna add them up now.
71.
71. I came with 70, so close because of the approximation. I bet you. 70. I didn't do this math. I did all of them together. DJ, that's what.
The fifth one is 5.
The fifth one is 5. And I need a third part to verify that. We have disagreement here.
Now you have 3.
Three.
45% is 10.
You can't find a
45%
gentleman.
of 10 is 4.5.
That's all.
Don't do it in your head, Mr. Nelson.
It's
No,
2.7.
I had 20 out.
Yeah, it is.
Did
when
you?
you round up to
Okay.
3.
We found the discrepancy here. All right, Mr. Bab, can I move to the next one? Or
What is the total now?
oh, we're gonna total now. Everybody's okay now? We're gonna add them up. Equal 171 M, right? 171 M. Now, since you guys are
It's 71.
now 171, just 71, and I was so excited about 71 M. Okay, I have my. Yeah, I have 70. Why did I get that one changed off? The same thing. Neutral, ground, bonding. This is number 5. Going to Mother Earth. God bless her heart is always number 4. This is number 1. This is number 2, and this is number 3. Right? Isn't that what we numbered all our stuff? And all the welders are sitting, minding their own business here. One, two, three, four, 5. Were they 5 or 6? They were 5, right? There's 6. Okay. Here's my panel. Here's my panel, guys. And I need to size this panel. The way we size the panel, we group them all the way. The voltage system as, let's make this voltage system 480/277 volt. Let's make it a 480/277. I just like to do 480/277. Anybody has a problem with that? If you have any problem, meet me in the parking lot.
Let's go 13A.
13.8? No, that's too big. 13.8 would be too big. 471 amps. If the amps were higher, 4,000 amp would make sense. Even, yeah. But guys, the idea, if you have a 480, use 480 all the time. Okay, so let's go size number 1. Very easy, very simple. Number 1, guys, which would be panel size. Panel size. Mr. Erbab, you take the 71 amps, and it's a 3-phase, so please go under 3-phase. 71 amps, take it all the way to D and Walt under 3-12. What size you guys come up with? 100?
125.
125. You don't have a 100 amp panel for 3-phase. They have a 100 amp load center. So 125 amp. So my panel, Muhammad, my friend, is going to be 125 amp panel. Okay, piece of cake, Chad. Let's go number 2. Number 2 is overcurrent protection device. Overcurrent protection device, you're going to take the same thing, 71 amp, take it all the way, since it's a panel, take it to 240.6, or you can take it to DeWalt. What's your next standard overcurrent protection device? Do we have 75? We don't have 75, so that's 80 amps. Okay. I'm going to go strictly by the code. Some of you guys might say, Chad, I'm just going to make the overcurrent protection device 100 amp panel, 100 amp, 125, and pull 125 amp cable. Be my guest. But I'm going strictly based on the load. There's no future expansion here. Have you guys noticed that? What if I want to add another welder? I'm going to be doomed. I'm going to go strictly based on the load. But in a case like this, you might have to ask yourself in real life, you know what, 80 amps is nothing. I'm going to go up it to 125, design-wise, and size everything for 125. That's your idea, your design. We'll go strictly based on the code. Number 4. Number 3. Number 3, what is it? Number 3, guys. Number 3 is a conductor. Feeder. Feeder. For feeder, I always say match overcurrent protection device. Next to it, put CSK Chad Kearney's idea. Because you can go actually on size based on 71 amps. You can. So what's my overcurrent protection device? 80 amps. Since it's less than 100, where would I strictly go? Less than 100. 310.15 V16. I go under 60. Strictly speaking, because it's less than 100, I'm going to go strictly and size from under 60. What did that give me? Number 3. How many? Look at the system. 4. 4 conductors. I have 4 conductors. Number 3, A, W, and G. Again, in real life, guys, you might sit there and say, you know what, it doesn't make sense, since I'm going to go, the smallest panel that's worth putting in a commercial building, guys, the smallest panel is 100 amp. The smallest panel. It's not worth putting in a commercial building a panel less than 100 amp. Okay? But this is strictly based on the code. No ideas, no preconceived ideas. No preconceived ideas. Any question? Jim, my friend? Camille?
So you'd have,
Bill? Good?
you'd have 125 amp panel box, but it wouldn't have a main breaker in it.
It will have the breaker will be 80 amp. What's wrong with that?
Why would you?
Oh, that's exactly what we just, why don't you just make it, since it's a small,
1.5 probably.
yeah, absolutely, that's exactly what we were just thinking, for future expansion. You can, there's nothing wrong. We're going strictly based on the code, guys. Right now, there is no room to expand in this panel. That's where your idea comes, is I'm gonna make a 125 amp panel for future expansion. But if you go from 600 amp panel into a 1000 amp panel for future expansion, somebody will start questioning your judgment.
You don't.
Okay, number 4. Number 4, what did we say number 4? Grounding electrode conductor. Was it number 3, Brooks? The conductor was number 3. So you take number 3, Mr. Erbab, and you take it to table 250.66. I hope I repeated myself many times, guys, in table. Hopefully we'll stick in as you keep, because this is over and over and over. We'll keep sizing up. Number 6, 8, number 8. Number 8. AWG. Now, let me warn you about number 8. If you use a grounding electrode conductor less than number 6, you have to provide a physical protection for it. So if you bring that number 8 here and you bring it down outside, the inspector will force you to put it in a PVC Schedule 80 for physical protection. So that's very common, guys. That's why a lot of people, even though you're allowed to go number 8 by code, just leave it as they go to number 6 because you don't want to put physical protection for it. Just FYI.
For number 8 you do?
Number 8, yeah, or less. Anything less, number 8 or less, you need physical protection for it. That's why when residential, if you do the math for residential, you end up with number 8, but we always pull number 6. You don't want to end up putting another conduit to protect it. And if you put it in an EMT, you have to tie both sides of the EMT, lug it, the conductor, so create more work for you. Okay, but strictly based on the code, number 5 as main bonding jumper. By the way, I'm assuming all these are services, guys. They're services, they're not panels. That's why I'm doing that. Services, meaning coming from Excel Energy to the shop and feeding strictly these loads. Which you could or could not. So the same thing, Mr. Abed, we take the number 3, you take it to Article 4, Article 250.28. 250.28. It refers you back to table 250.66, and that will get you again number 1 here. 1, number 8, A, W, and G. Does it need to be insulated or covered? No. Could be bare, it could be insulated or covered. Both of them. Both of these conductors can be bare, insulated, or covered. Any question, guys? Any question? Now my question for you guys, if you have a shop and you have some lights and some receptacles and some other HVAC equipment and you need to size them in for it, what do? You do the calculation that we did for all the welding equipment on the side, do the lighting calculation, the receptacle calculation, HVAC equipment calculation, add all of them together and size you main. So you added the welding loads to the main. If it has a welding loads and other loads, which is most likely will. Every welding shop has lights. If I have a service panel here, guys, feeding the welders, where are you going to feed the lights from? Most likely from the same panel, if it's a small shop. So you're going to add the lights and the receptacles, and which we did commercial, the whole commercial calculation, exactly the same. HVAC equipment, heating, cooling for the building, add it exactly like we did to the welding load and size your panel. But we're strictly kind of looking at the welding loads only. When we go to the commercial building, guys, we're going to have process loads. We call them process loads. There's machines sitting in a manufacturing floor doing things, making things. You're going to add them exactly like if they were welders, not the same calculation, but lump sum them in certain way and add the light to them, the HVAC equipment to them, the receptacle to them, to size them in. I hope you're getting into the rhythm of doing it.
signal processing amplification, is that what we're gonna put in on tonight?
No, I hope not. I hope not. Okay, can you guys? I'm gonna do two things. I was planning of moving to the transformers today, but since we're in the welders, we sized the service. I'm gonna go size a branch circuit, a welder branch circuit, right? Because that's what you're gonna be. I size the service coming in here. Now I'm gonna take a feeder and feed a welder sitting right in here. Size the conductor and the overcomplication device for the welder. For the welder. Okay, let's do that one. For this, I'm gonna pick one welder. Let's do. I'm gonna do it first from the first example that I did, guys. I'm going to pick the first one, that 50 amp welder. Do you guys remember that 50 amp welder? I'm going to go size a branch circuit for it. 50 amp welder. What was the cycle? 100%.
Yep.
So okay, so everybody's with me. I'm going to go multiply it. Okay, overcome protection device for conductors. Okay, so we're gonna go do the conductor. All right, let's do. You know what? Because I'm gonna use the cycle, I'm gonna go pick. If you don't mind, I'm gonna go pick the 40 amp. I'm gonna size a branch circuit for the 40 amp. DJ, can you remind me? It's motor number 2, or welder number 2. It's a welder arc. We're gonna do an arc welder, number 2, 9040. Anybody can remind me of these when I go? Because I'm gonna forget. 29040, okay? And it's what is it? It's a motor. Don't forget that value here. All right, everybody can remember that before I go copy it. DJ, did you stick it in your mind? All right. Okay, so this would be number 4, number 3, branch circuit sizing for arc welder. When I do branch circuit sizing for arc welder, I just want to little bit draw the attention to the panel that we just sized, guys, here. And I'm going to go and overcome protection device and go to my welder. What was it? 40 amps? 40 amps, right?
Yep.
40 amps?
You want the one calculated or?
No, just want the amp of it. 40 amps.
Value.
What was the cycle in it?
It's 90.
90% cycle. And what was the, is it motor or non-motor? It was motor. Motor. There's Jen. Okay. And Holly, what was the size of the panel, guys? Anybody remember what was the size of this panel? Just remind me of the size of the first panel that we did.
150.
This was a 150 amp, and it was a 150 amp panel, and the voltage was 208/120 volts. So I just went to the panel, first panel that we sized. I pulled one load, and I need to size the branch circuit for this load. Typical for all of them, guys. You're going to find it's typical for all of them. Okay, the first thing I want to size is number 1, the overcome protection device. The second thing I want to size is 1, 2, is the conductor. And the third thing is the equivalent ground and conductor, which is coming here all the way to the ground. This is number 3. So I need to size the equivalent ground and conductor, the equivalent ground and conductor, the overcome protection device, and the phase conductors. The phase conductors for this boy welder, Mr. Welder. For Mr. Welder. Now remember, this is a branch circuit. A branch circuit. Okay, individual welders. To help me with this, I'm going to go, to help me with this, guys, I want you to go to article, the same article almost, 630.11a. 630.11a. 630.11a, if you guys read through it, it will tell you how to size the conductor for the welder. And for the overcome protection device, so this is for where we which one are we sizing? We're going to size. I'm going to start with let's start with number 1. Number 1, overcurrent protection device. For overcurrent protection device, actually it's going to be a different article. We're going to go to 630.12a. 630.12a. if you guys read through 630 for overcap protection device, 630.12a, if you read through it, it will tell you you need what did they call it? 20% of the rated primary current of the welder. This is called rated primary current of the welder. Rated primary current of the welder. If you read through it, it doesn't tell you to modify it. If you read through A, for welders, each welder shall be an overcap protection device, blah, 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 200% of IMAX. I don't know IMAX. Alternatively, if the IMAX is not given, the overcap protection device shall be rated out or set at not more than 200% of the rated primary current of the welder. Not more than 200%, not more than 200% of the rated primary current of the welder. Okay? I want to emphasize not more than. So if you end up with non-standard, what do? You go down, not more than. Okay, so what's that? This is called the primary current of the welder, the 40. I don't need to do it, nothing for it. So I'll take the 40. Let's take the 40, multiply it by 200%. What's 200%? 2. That will give me what? 80 amps. Then you're going to take the 80 amps to 240.6. Is this a standard? 80 amps is a standard. If it's not a standard, what do? You go down. Does that make sense? If it's not a standard, you go down. So we happen to hit the standard, so we're good to go. Now, I want to bring to your attention, if you guys read it through, it doesn't say apply the table to it. It says the primary current or the what do you call the IMAX. I don't know what the IMAX of it. I'm going to use the primary current, which is that number here, primary current. So 200%, 80. If it's not had we end up with say 73, we're going to go down to, is there 70? There's 70, no? We're going to go down to 70. Am I clear about going down, not going up? Okay, so that's 80. The second thing, guys, number 2. Any question about number 1? So I sized the overcap protection device for that boy. I need to size the number 2 is the conductors or branch circuit conductors. Branch circuit conductors. Branch circuit conductors, guys. I want to take, if you look at the, if you read for branch circuit conductors, you need article 630.11a. 630.11a. Please go review it. If you guys review it for individual welder, it tells you apply the table to it. Apply the table to it. Okay? So,
Why isn't it 630.12b?
630.11a.
630.12b.
B is group of welders. Minimum conductor ambiguity shall.
That's overcut.
Are you 630.12? That's the overcap protection device. For welders, each welder shall have. B is for conductors. Conductors that supply one or more welders shall be protected by an overcap protection device. This is overcurrent protection device for conductors that's feeding welders. If you guys read B,
Aren't we sizing the conductors that are feeding the welder right now?
yes,
So why aren't we at 630.12b instead of 630?
because the B is still you to size the overcurrent protection device that protect the conductors.
Not the conductors.
So for conductors that supply or one or more welders shall be protected by an overcap protection device. They're talking about protecting the conductors. We will size the conductors first. Okay, so we size the conductor, branch circuit conductor 630.11. If you guys read through this individual welder, it tells you have to apply the table. Okay, so what do I need to do? I have my 40 times based on the cycle. What was the multiplier based on the cycle? 95?
Oh, I'm sorry, 96.
96.96 based on the cycle. And the cycle is, guys, the cycle is 90 and the motor generator. You go apply the table. apply the table. And I'm gonna add here, guys. Also, what was the table? This is table 630.11a. 630.11a table. So I need to go to 630.11a and 630.11a table. Okay, anybody can give me what the answer is? 60 some. 38 amps. Piece of cake. See, they allow you to apply the table to the rate slightly. Then you're going to take the 38, take it all the way to 310.16 or 310.15b16. What size would that give you? Number? Yes, sir.
So this is motor, do we have to use the
No.
25 or is it
They're not there. I would go, unless I know they're not motor. Do we know if it's designed A, B, or C motors? So I'll go strictly based on 60, based on 60. Thank you. I'll go strictly based on 60-degree column, unless I know otherwise.
Sorry,
Yes, sir.
that 96, isn't it supposed to be,
For a 90% cycle motor generator, the multiplier from the table is 96, right?
must be looking at the wrong
Okay.
chart.
This should be from table
630.11a.
611A. Yep.
Okay.
If you look at 90 cycle, under motor generator should be 96.
Oh, I was looking at 40, so.
Okay. 40 cycle. No, it's not 40
Yeah, yeah.
cycle. It's
Yeah.
40 amps. Okay, what was the size 8? Number 8? 3 conductors, number 8. 3 conductors, number 8. I don't need a neutral. A, W, G. How much current number 8 can give you? 40? Double the 40. 80. Going back to what you just asked me. That's how you check. How much current number 8 can give you? 40 amps. Multiplied by 2 because 200%, 80. And you can, the overcome protection device cannot be higher than 80. Looking at it backward. Had I came up with a number here that actually less than 80, you might have to up this one. Or lower the overcome protection device, either way. So, but most of the time, guys, if you size based on this, you're good to go. Any question? Any question about BC conductor? BC conductor, branch circuit conductors? Branch circuit conductors? So we size the overcome protection device, we size the conductor. The last thing is the equipment ground conductor. What do you think the equipment ground conductor need to be sized for, guys? That's easy. I'm going to go back here, number 3 or 4? Number 3. Number 3, this is ground, this is EGC. E, G, and C. Equipment grounding conductor. This is sized based on overcome protection device. So 80 amps. Take it to which table? Table 250.1, 2, and another 2. Number 8. Number 8. Number 8. One conductor, number 8. Now here's a question for you. If this calculation end up with number 1 out, say just you did it here and end up with 1 out. And what was the phase conductors? We size them at number 8. You don't have to go. The equipment grounding conductor does not need to go to be higher than the phase conductors. That's what the code says. So if this calculation end up with a size larger than the ungrounded conductor, the phase, stick with the ungrounded conductor. Again, I can't emphasize, we end up with an 8, 8, we're matched. But had we end up with a number 4 here, you can put number 4, but the code says, don't worry, match the ungrounded conductor, not the neutral, the ungrounded conductor. And that happens a lot, guys, in motors. When we size for motors, because the overcome protection device be way oversized, you end up with a ground equipment, grounded conductor larger than the phase conductor. It doesn't make sense. You know, because the phase conductors are going to carry the short circuit too. If you have a short circuit, the ungrounded conductor will carry the short circuit as well as the grounded conductor. So it doesn't make sense to have one of them oversized more than the phases. So the phase will be the max no matter what. Okay. So if I want to put a note for you guys to remember, equipment grounding conductor shall be equal or less than ungrounded conductor. That's what I'm saying. The equipment grounding conductor shall be equal or less. Doesn't have to be more. Equal or less. I know that somebody. I'll get it to you. I just can't recall it off memory here. I'll get it to you. Equipment grounding conductor shall be equal or less not the neutral. I don't want you to get confused between the neutral, the ungrounded conductor, which is the phases. Okay.
Why does America put a bigger EPC in?
Just wasting money.
Well, I saw it from obvious, but beyond that,
Resistance would be more too.
That why do they want to limit it to? If you have a short circuit in a circuit, here's a phase A and here's a ground, and you have a ground fault, right? So the short circuit is going to go through the phase, right, and back through the ground. So if this is number 4 and this is number say number 8, doesn't make sense. If this is number 8, this doesn't have to be 4 they're carrying the same short circuit. So that's kind of the argument is, if you have a ground fault, here's my phase, here's my ground, and the ungrounded conductor will carry the same ground fault as the equipment grounded conductor. So it doesn't make sense for the equipment grounded conductor to be larger than the phase conductor. Any question, guys? I do have one more example before I let you go. One more example. Welder resistance. Okay, let's go grab a welder resistance, the same thing, the 40. DJ, hold your horses here and grab. I'm gonna go do the grind circuit for this 40 here. Okay? Can you remember that? It's number 240 and 40M. 40M. I'm gonna go grind circuit that way. Now this is welder resistance. Welder resistance welders. 4040, was it 4040? Okay. This will be number 1, 2, 3. This will be 4, right? This is number 4. Branch circuit for resistance welders. Welders with a resistance. What does that mean? Here's my overcome protection device. Here's my panel. This was 80, right? This was 125 amp. And then I'm pulling to my 40 amp. And what was 40 cycle, right? 40 cycle. Okay, so here's what I'm sizing, guys. I have my main panel. I'm pulling a conductor, and I need to size the same thing. Number 1, number 2, and guess what? I'm going to go all the way here to ground, and I'm going to pull number 3. I'm sizing 1, 2, 3. The phase conductor, the overcome protection device, and the grounding, the equipment grounding conductor. Okay, so I'm going to go size the conductors. To help me with this, guys, I need to go. Any question about this? I'm sizing a grind circuit for a resistance welder, a welder with a resistance. I want to size first. Number 1 is the overcurrent protection device. To help me with this, I want you guys to go and read this article. I want you to go 630.32A. 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 If you guys read this one, and also A and B, A and B, A and B. But in particular A, 630A, it says overcome protection device shall be provided in 630, okay, B for A, for welders. Each welder shall have an overcome protection device 300% rated if the supply conductor for, okay, device or set 200% of the, see the bottom says 200% of the rated primary current of the welder or overcome protection device shall not be required. If the supply conductors for the welder are protected by an overcurrent device rated or set at not more than 200% of the rated primary current of the welder, a separate overcurrent device shall not be required. Each welder shall have an overcurrent protection device rated or set at not more than 300% of the rated primary current of the welder. So the key point is 300% of the primary rated. If the supply conductors for the welders are protected by an overcurrent protection device rated. So I don't want you to get confused, guys. They're talking about right here at the welder. If you put an overcurrent protection device here and rate this overcurrent protection device at 200, then you don't need another buoy here. Okay? But if you size it, each welder shall have a 3. Otherwise, if you will put it right in here, right at the welder, 300%, right at the welder. If you will put it right ahead of the welder, like we're doing, right here, 200% of the, exactly like we did, 200. And if you guys read it, it says each welder shall have an overcurrent protection device rated or set at not more than 300% of the rated primary current. That's right here, right here. Now, if I decided to move it up because I don't want to put 2 of them, if you put one here, by the way, you still have to put one at the top. You still have to put one at the top because of the conductors. So, but I'm going to do it at the top anyway. If the supply conductors of the welder are protected by overcurrent protection device set at not more than 200%, then you do not need a 300% here. Okay, with this, I'm going to go then size based on 200%, and that will save me putting 2 overcurrent protection devices, one here and one here.
What would be the point?
What would be the point?
Having two
Good point. You might be in a situation, guys, where the welder would not start with a 200% every time you start it, because you're arcing, you're making short circuit, it will trip. So they allow you to oversize right next to the welder, oversize the overcurrent protection by 300% versus undersized at the feeder. That's the only thing I can come up with. But both of them are in series though.
It's on the same.
In series. In series. Both of them are in series, so they're going to be seeing the same current. That's what you're saying. If they're in series, they're going to be seeing the same current. You're right, except they could be different type of circuit breakers and fuses with different characteristics. And I'm going to leave this one for the short circuit guys. You can have a 200 amp fuse here and a 200 amp circuit breaker here, and the 200 amp fuse will not trip, but the 200 amp circuit breaker will trip, or vice versa, because of the characteristics of the fuse, the way they design them, the trip curve, and so forth. So it would make a sense when you look at the current characteristic curve of the fuse or the circuit breaker that they're using either here or here. So since I don't know much about the welder, and I'm going to go size just the branch circuit, I care less about protecting the welder here at the time. Otherwise, I'm going to go size based on 200 amp, 200%. Based on, here's the primary rated amps. So I'm going to do the same calculation guys that we did. I'm going to have my 40 amp multiplied by what? By 2. That will give me 80 amps. You're going to take the 80 amps again to where? To 40.6, and that'll get you an 80 amp circuit breaker. If it's not a standard, oh, thank you. Is that from your wife?
Yes.
Oh man, thank you. That's what I
When
need,
you
man.
get a break, it's a brain break, a little brain energy. That's
Yeah, thank you, my friend. I appreciate it. So, I like people who feed me, man. 80%. So it's 80%. Spencer, if that wasn't a standard, what do you do? Or custom design yourself a fuse and pay an arm and leg.
300.
If you go up to 300, you can go up 300 here. Then you have to put it right in here. Then, okay, what would I do if I want to go up to 300? Here's what you're going to do if you go to up to 300. Then your conductor here has to be sized for 300%. You know, I can go and put my overcome protection device height 300% right here, or right here, mostly right here. But my conductor, then you have to up your conductor size. You up your conductor size.
Sure, but I guess Mike Holt breaks it down a little differently. He
Okay.
says, each welder must have an OCPD about not more than 300.
That's
So would it make sense just to go
Right here.
300 from the start?
yes. Then your conductor have to be sized for 300. You can absolutely, absolutely. Okay, so that's my number one. Number two, my friend, is the conductors. Let's go and size the conductors. Conductors. For conductors, individual, the ambiguity of the supplied. For conductors, I want you guys to go look at 630.31. Number two, conductors or branch circuit conductors. Branch circuit conductors. To help me with this, I want you guys to go to Article 430, 630.31. In particular, A2. A2. There are many ways of doing it. I want you to look at A2. If you guys look at A2, the ambiguity of the supply conductor for the welder, blah, 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 specific operation for which the actual primary current, which is we have, and the duty are known, remaining, shall not be less than the product of the actual primary current and the multiplier. Under number two, if number one applies to you, if you have the value for number one, you use number one. We don't know anything about all what we know is the cycle here. So if you guys look at this, if you read through it, it'll tell me, I'm going to take my 40, multiply, what's the multiplier for a 40% cycle? DJ? 60? 63. 63. What was the amp on that one? The amp? 25. Yep, 25 amp. Okay? Then I'm going to take 25 amp, take it all the way to 310.16B. Oops, 310.16. Let's just use the 2008. 310.16 under 60-degree column. What would that give you guys? Number 10. Number 10. How many conductors? 3 conductors. Number 10. AWG. Well, let's check. 3 conductors, number 10. Now remember what B says. B says if you have a conductor, they can't be protected more than 200% of their ambiguity. Okay, so I size it based on number 10. I'm cool. I'm going to go check. Here's my check with B. I'm going to go take, so I have number 10. How much current number 10, guys? 310.16 under 60-degree column. How much current can I give you? 30 amps. 30 amps. Okay? Now, if you take 2 multiplied by 30 amps, what do you get? 60 amps. That's the max over current protection device for conductor. Have we exceeded this on this particular conductor? Yes, we put 80. One more time. We size it based on this. 10, right?
Well, it should be, well, I mean, we have to go bigger than 10, but based on the table, it would be 12. For 25.
Under 60-degree column. Under 60-degree column. Small conductor rule. Small conductor rule apply for this one. These are welders. They're not motor. They're not transformers. So you can't use this number 10 on what's the amp? Amp is 80 here even. And what's the amp? The amp in this one is 80. So your conductor 310.16. 12 can give me 25 under 60.
Yep.
So that's only 20 to the small conductor rule.
Did you look at the? Did you look at NEC 2011?
We're not on NEC.
NEC. If you guys do it at NEC 2011, that's solved. Right now it's solved because they move you to 10. But you're absolutely right because these are the overcome protection device. You're going to end up strictly based on this table with number 12, with even number 12. But we're going to change it anyway.
Right.
So it'll be number 12 here. So let's go to number 12 here, just strictly based on the table. So what's number 12 can give you? I know it's going to change here. Number 12, guys, how much number 12 can give you? Number 12 conductor can give you 25, thank you, 25 amp. If you multiply 25 by 25, what do you get? 25 by 2, you get 50 amps. 50 amps. This is the maximum overcome protection device for this conductor under these circumstances. Have I exceeded it? Yes. If I use 10, would I be exceed 10 too? Look at 10. We just calculated. So I have to go all the way to number 8. Number 8 can give me 40. 40 times 2 give me 80. Check. Done. 80 amps. So what conductor size do I need for this application? Number 8.
You don't apply the small conductor rule to welders?
No.
No.
No. Can you guys go review 240.4 is a small conductor rule? Can you review it? There's a list of, yeah, is it excluded? There's a list of exclusion from the small conductor rule. Number 8 is the cutoff. That's it. But did you see where all this, guys, is coming from 630? All this calculation, 630 dot, 630 dot what? 630, 25, 650, come on here, 630, 625, 640, 630. Okay, so where am I here? Which page are we in here? 630. Lost my train of thought with that one. 630. 630. Here we go. Okay, welders. 626. No, Chad. No, no. 630. 630 dot 630.32 B. 630.32 B. Very important. Based on this, here's the conductor that you need to size. Here's the conductor that you need to size. Any question, guys? Any question? Let me repeat before I repeat myself, I'm going to go to the equipment grounding conductor, guys. The last one, which is 3, equipment grounding conductor. Well, it was 80 amps, right? 80 amps. I'm going to go to table 250.122. That will give me, we did that one. That will give me number 8. Give me one conductor, number 8. Right? Is that what we did before? One conductor, number 8. Based on 80 amps. Where does the 80 amps came to be? That's the 80 amps of the overcome protection device. I can't emphasize, guys, for the branch circuits, that B to review and go check yourself. Go check yourself. And again, Brad, this problem that you just, it's solved in 2011. 2011 right now, number 12 cannot carry more than 20 amps under 60-degree column, guys. They solved it. So you're not, have we doing it under 2011? This must be number 10 now. Good stuff, man. Any question, guys, about branch circuits? Brooke, did we do anything wrong? Any, no mistakes?
Can you go back?
Oh, sorry, Mr. Beb. Any question, guys, about 630.32? I am Spencer. I'm sorry, when you get into special occupancies and special equipment, things start not black and white like we do. I mean, you have to kind of monkey around in a couple places. So it's you might have to check 2 places besides the conductor. Unlike regular stuff that we do, these are welders, special equipment. So you have to kind of monkey around to get the answer. But not a whole lot. It's just 2 jumps here to get the answer. Any question, guys, for these welders? Now, if I take you to a shop and ask you to size a branch circuit for the welders and the service, would you be able to do that? No problem, Chad. Mr. Buell, Any question, my friend? No. No? Did you install this stuff or no? Welders and all this good stuff?
Mostly it's, temporary.
Temporary.
During the construction,
Did you guys do it?
for the iron workers,
Okay.
otherwise, we never had to do a manufacturing shop where we need under 150 for temporary.
That's good.
Oh,
Any question for Chair? Just to summarize, we sized a feeder for arc welders and resistant welders. We sized a branch circuit for arc welders and resistance welders with resistance. I wanted to jump into the transformer, but that will confuse you guys today. Tomorrow I'm going to jump into doing transformer calculation, and then hopefully by the end of this week we'll close these two calculation chapters, so we can jump after the holidays with the lighting calculation. So my plan tomorrow is to do, if you want to go ahead, plan ahead, I'm going to go over transformer calculation, sizing, overcome protection device, cables, monkeying around with transformers. Any question, my friends? Any question? Well, either put you to sleep or everything is as clear as good or clear as mud or... Oh boy. You need to go over anything? Anybody wants to go over anything, guys? That's all I have. I will put these one in here on the network before I lose them like I lost other things. I'm gonna